Hi guys, Igor again in the next episode of going from Python to Java. Let's go. Last time we just rewrote the flow control overview script, and as you can see we have quite a few more to cover. We'll probably not go over all of them today, but let's cover a few. So I think the next good candidate is this one, functions overview. Let's see if it works. So let's go to the terminal and type Python 3 functions overview. Okay, we have some output, and we need to convert that script to Java. Java, everything is a class, so let's create functions overview class. Let's create main method. And what do we have here, guys? A few functions, and then we have some variables declarations and some statements. Okay, so let's go with the functions first. Add the function. So static int, because we want to use it as a function, not as an object method. So we need to have static modifier, 2 integers, and some print statement like that, calling add with these two guys, new line AB, and let's return A plus B. Next we have nested add. Yeah, and unfortunately in Java we don't have this concept of defining function scoped in a function, but we can emulate that. I will show you how. So we can use lambdas, so we can use functional interface and do something like that. So add A plus A and B. Oh, yeah. We need to name them differently, like that. Here, let's say that calling nested add dot and x and y. Okay, so let's return x plus y. Okay, and what we did here, guys, so in Java we have functional interfaces, and functional interface is just interface where you need to define only one method, implement only one method. And thanks to that, you can use it as a function, or use it as a lambda, functional, and functional lambda, functional expression, and just a function. There are a few names of them. And because in Java everything is an object, you don't have really function. You can have variable as a function, or you can have file with only functions, so we need to use methods like that. And now you will say that we call add apply. So as you can see, it's not really a function, it's an interface with one method, apply. Alright, then we have add function, like that. and it returns functions. Okay, so Java, again, we'll use functional interface, but different one. The one that returns integer, and it doesn't require arguments. This one returns integer and requires 2 integer arguments. Yeah, I skipped that in the explanation, and here we say that a plus b. So functional expression, and we use arguments that we got there. Okay, there are quite few more, but let's see if we can write some statements actually. We have a variable, we have b variable, we are printing something here, just a function call. Here we have nested add. Yeah, so let's actually go to the file, to the folder where we have our Java classes, and let's run function Java functions overview Java. This will compile this file in line and run it. Okay, let's see. Going out, yeah, b should be 4. It should be the same. Yeah, the beginning is the same, so let's go further. What we have there. Then we have default arg function. So let's define that. In Python we can have named arguments and default values of them. Like here we can say b is something. We can also do similar thing with a. Java we don't have that, so we emulate that in the following manner. We say default arg function a and p. Okay, we say that print calling default arg function p d. Okay, and yeah, that's it. We don't return anything, so void. And to have b with some default value, we'll define this function again, but we'll hardcode there null, because in Java we have null, not none, and we need to use integer, so object version of int actually. Okay, so we have that. What else? Then we have variable args function. So let's define that. Variable args function. In Java we are doing this like that. This is pretty similar. So variable args function, and we need to use arrays to string actually, because this is an array in Java, and array by default doesn't have a really good string representation, so let's do that. And the last one, we have variable key value, key or keyword args, key value keyword args, and unfortunately we don't have similar thing in Java. We can only do something, we can accept map really. So variable, let's do something like that. We can take a map with the key of string and value of object, like that. This will be most similar, I think. Keyword args, key value args, and let's say variable keyword args function like that. And yeah, we have all functions defined. Let's see what we do right there. Yeah, nested that default arg function, and a and b in the right order. We don't have to do that in Python. Okay, some colons there, or some periods. Then variable args function, This is the same, really. Then we have a list. So something like that. Then we have unpacking list. So it would in runtime it would be 2 and 3, same as here, but 2 and 3. In Java we can achieve that, even though it doesn't make sense, but synthetically it would be the same with that syntax. With that, then we again have a few periods, and then we have variable keywords, keyword args. So here we can do empty map. Here we can say A, B, C, the argument like that of different type, integer and string. And here we have unpacking. Yeah, we can't really do that in Java in that context. Right, a few periods. What we have then? Function as a variable. In Java we can do this like that. So functional interface and the method reference like that. Then we will print it, apply 2 and 3. Then we have closed add variable, and we are using add function, which is a function that returns function. And in Python we are using it as normal function call. In Java we need to do something like this. So we have functional interface supplier with one method, and we are calling it. And because it has one method, we can use it at Lambda in Java. Okay, and we have Lambda var as the last one. And again, this is functional interface, but defined in line. And yeah, in Java we can't shadow variables like that. So if we would say A and B, we can't do that because we have them right here, and in Python they will be shadowed, so they will be hidden. So we need to state this like that in Java. And here again, lambda var Let's apply. Okay, and it should work. So let's run it and let's compare the output, guys. Okay, starting from the top, calling add the same, calling nested add the same. This is the same, none and null. This is the only but expected difference. Then we have variable rx function. Yeah, we have rounded brackets here because this is a tuple in Python, and we have list in Java. We have tuple with the list. Here we have list array with the list because we are calling arrays to string, and this is how it works. And in the last one we are unpacking the list to two arguments, and we are doing something similar in Java, giving it okay, refactoring of IntelliJ has changed that, but we want to have it like that, guys. Okay, it is the same again. Then variable keyword args, similar output. And the last one we didn't do intentionally, right? Then we are calling add function. So here we have it, guys. Functions overview, rewrote to return to Java. Let's go with another one. Let's go with maybe collections. I would say are interesting. So let's check Python that it works. Yeah, it works. So let's create, you guessed it, collections overview in Python in Java with main method. And let's go with the implementation. So what do we have in Python? We have numbers tuple. So tuple in Python is really immutable list, more or less. We don't have it in Java. I mean, we have just lists, mutable and immutable, and you can create immutable list Java, for example, like that. You can do this, and if you will call add here, it will throw an exception actually. I wanted to call Python, guys. Java collections overview Java. Okay, unsupported operation exception. So we'll skip tuple, we'll just do list. Then we have a set. We'll do that. And what do you have? 1, 2, 3, and 4. And we will get exception again here. Let's see. But for different reason. Yes, duplicate element. So with that implementation of the set, we can't have that, but with others we can. I mean, the data will still be unique, but we will not get exception thrown at us. Okay, then we have numbers map like that, and again I see that we have duplicated element here. So let's see that we will get exception thrown at us. Let's see that. Yeah, duplicate key. So let's remove it like that. And let's go with that numbers map. Then what do we have? We have tuple of len. Don't have tuple, so we have list of size actually, because we have size method, Java, not len. And here d, as we know, and list. Okay, and we have numbers, list size and numbers. Something like that. Let's run it maybe. Yeah, we have list of size. And let's go with next one. So set of size. This will be the same. Like that. Size and numbers. Set. And map. So map of size, numbers, map, numbers, map, then new line. And what do you have? Then we are iterating over list. So let's also do that. Python we have in, Java we will do numbers literally the same, curly brackets, or we actually can show that possibility. Iterating over map. Here let's do this in a different way. We can do, for example, for each, we get key and value, and we can say using lambda expression print that key value line. That. Okay, what do we have then? Maybe let's run it. Okay, it works. So then we have list collection comprehensions, so operations in place on collections. In Java we can do this by just writing functions or by using so-called streams. So let's use streams like that. So numbers list stream. We have stream, and now we can filter, map, sort, and do many more operations. On that, we just need to filter, guys. So if n modulo 2 equals 0, then to list, or we can specify how we want to transform to what collection we want to transform the final stream. So we can say collectors to collection and pick another list implementation like linked list, for example, and with all the numbers list. It is always almost the same. Just filter n and modulo 2 equals 1 and to list, and odd numbers reversed list. Here in Python we have sorted method, and to sorted method we are giving list. In Java we can do this by using streams. Also here we see sorted, and we used reverse order comparator. Okay, then we are printing out the results. Okay, even numbers list like that. Then odd numbers list like that, and then odd numbers reversed list like that. Okay, let's run it. We have the same output, guys, so far, so let's go further. List mutation. Okay, string list. So string list, let's pick array list as implementation, and let's add some elements to it like that. Then extend. So Java you have add all, another list like that, and then we are printing it like that. String list, then new line, and then we have sublists, guys. Sublists. So in Python we have this nice indices or index operator. In Java we have method for that, which looks like that. Sublist, string list, sublist, 1, 2, 3, and here we have reversed list. So this means that we'll go from to index, but -1 means reversed order, so we go from 2 to 1 to 0. Actually, is it true? Yeah, I think it is, because here we have this list that we are reversing here, and as you can see we have A1, B, and A. So in Java we can do this by using streams, or we can do something different. So we can say reversed string list, for example. Here is how we can copy it. Collections reverse, and now we can say that reversed sublist is that. Reverse sublist, reverse string list, sublist, we should take from 0 to 1, because we have reversed it. Let's check. No. 0 to 3. Also no, because yeah, I think we should, yeah, let's do this in a different way. So to reversed string sublist, here we will say that or not. What do we need here, guys? We need it from really 0 or not. Yeah, from 0 to 3 in a reversed order. So if we have this reversed, guys, okay, so we have that, and we should take it from 1 to 3. Yeah, that math. So reversed sublist like that. 1 to 3 should be the same. 1 to 3, it is almost the same. 1 to 4. Yeah, it is the same. Okay, and the last one. The last one is dictionary. Mutated, so string map. Let's take hash map as our implementation, and let's put some values and keys there like that. Okay, p-value, and here we want to put string map, not list, put all items from another map like that. The value, and that's all, I believe. We just need to print it like that. Yeah, let's see if the output is equal. Tuple we don't have, list have. We have that, set of len, set of size, map of len, map of size, it is the same. Iterating over list, iterating over map. Let's actually run it to show something. Oh yeah, we have it. Iterating over map. In Python, we always have we have guarantee to of insertion order in the map. In Java, with the implementation of map off, and with the hash map we don't have that. To do that we need to use linked hash map, in case you are wondering. So here the order is different. Order is different than the insertion order because we have inserted A, B, C and D, and here we have A, D, C and B. Okay, even number list, odd numbers list, the same. Odd numbers reverse list, the same. Mutated string list, same. Sublist is the same, and mutated string list is also the same, guys. So that was collections overview. Let's do another one, maybe something quicker like exceptions. Actually, let's see if they work. Yeah, they work. We have exceptions. Okay, so as previously, let's create exceptions overview class like that. Let's create main method. What we have? We have custom exception. So let's let's create custom exception, extending checked exception. We'll see what does it mean in a minute. Here we want to have custom exception like that, going super. This is how we do this thing in Java. Yeah, and that's pretty much it as far as custom code is concerned. Here we are catching any exception. In Java it is done like that. Catch exception. Yeah, maybe one more thing. We've checked, in Java we have checked and unchecked exceptions. And the difference is that with checked exceptions, you need to state that you throw them in the method signature. So if you say throw new custom exception, which extends exception, this code will not compile. Let's see. Exceptions of Java. Yeah, because unreported exception must be caught or declared to be thrown. So that, or with being more specific like that, the code will be compiled. Okay, but we don't need that because we will catch it like that. So in Python we have rise, in Java we have throw like that. We are catching it like that. We can say that system error print line handling exception. Python they have some strange trace back. Here we have stack trace. Here we will print new line to the error, system error output, error print string. Okay. And here we are catching specific exception. Actually the broader one is throwable because exception extends throwable. Throwable doesn't extend anything. Okay, here they have some key error. Here we can do try to mutate the mutable list like that. Let's catch illegal operation or not, illegal unsupported operation exception, and let's say that we have can't add to immutable list, for example. Okay, let's run it, guys. Okay, obviously the output will be a little different, but let's compare it. In Python we have traceback, handling exception, we have a line where it was thrown, and in what module? Module, okay. Module doesn't have a name, interesting. Oh no, we have file name and a line. Same here, Java. We have exception name. We have line in the file. We also have class name, which is file name, and yeah, what else? Exceptions, whole stack trace, and same really here. Okay, guys, I think that's enough for today. But as I said, we have a few more files to cover. We'll cover them in the next episode. So if you enjoy this type of content, like the video, subscribe to the channel, and I see you in the next one. See ya!